Good morning, students. The last video we saw the F block elements. Okay, so in the F block elements, studied about the position, electronic configuration, oxidation state. Okay, children. For this video, we continue the F block, that is elements topic, that is lanthanide contraction. Okay, so now the topic is lanthanide contraction. So contraction means it is decreases from the normal. Okay, so here decreases mean talk about the size. So the size decreases. So lanthanoids, that is we know that is 14 element it is present, that is cerium to lutetium. Okay, so atomic number 58 plus 71. Okay, so now the size, that is atomic radii, the ionic radii decreases from cerium to, that is the lutetium. So the size of M3 plus ion decreases from lanthanum to lutetium. Okay, it is known as lanthanide contraction. Very clear, children? The steady decrease. Okay, so this is the definition. So the steady decrease in ionic radii of M3 plus ions in lanthanides. Lanthanide series is known as lanthanide contraction. Okay, so the steady decrease in ionic radii of M3 plus ion in lanthanide series is known as lanthanide contraction. Okay, the textbook give the graphical representation. Atomic number. Okay, so here that is atomic radii or ionic radii, whatever atomic radii, ionic radii. So now gradually that is decreases from lanthanum to, that is the lutetium. Okay, so this is known as lanthanide contraction. Okay, children. So now we are going to see why this that is what is the causes of lanthanide contraction. Okay, why that is lanthanide contraction it occurs. So now study the next one, causes of lanthanide contraction. Causes of lanthanide contraction. So here that is causes of lanthanide contraction. In lanthanide series, that is cerium to lutetium. Okay, so now that is a difference. For example, that is cerium, praseodymium, neodymium, promethium, okay, samarium, europium, gadolinium. Okay, so now for each element the atomic number difference is 1. Okay, only one atomic number it is difference. So for here atomic number, this one 58, 59, 60, 61, 62, 63 and 64. Okay, so up to that is the lutetium. Okay, so gadolinium. So next one that is terbium, dysprosium. Okay, so 65 and 66. So next one that is the holmium. So 67. So next one terbium. Okay, so holmium, that is erbium. Okay, so next one thulium. So Tm. So 67, 68, 69. So next one ytterbium 70 and lutetium 71. So see children, here different 58, 59. So difference is that is 1. So atomic number difference for each and every step, that is only 1 electron, that is we are added here. Okay. So now atomic number mean is nothing but number of electron. or number of proton. Okay, so children, once again I recall this series. Okay, so along with me now want to see, that is say the words cerium, praseodymium, neodymium, promethium, samarium, okay, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, YB, okay, so lutetium. This is the lanthanoid series. Totally 14 elements present. Okay, already we saw the previous video. Okay, children. So now let us see the lanthanoid structure. Okay. So now center of the atom is the nucleus. We know very well. So next that is the electron revolve around the nucleus. Okay. Revolve around the nucleus. Okay, children. So now here this is the nth shell, outermost shell. This one n minus 1. Okay. So this cell is n minus 2. This one penultimate shell, P-N-U-L-I-T, penultimate shell. This one for anti-penultimate shell. Okay, so here alone the F electron. Okay, so this, that is the shell, that is F orbital, that is electron added, that is 1 by 1. Okay, children. Okay, so this one F orbital. So now that is causes. Now we are seeing the causes. Okay, so now the size increases and decreases. It depends on the, that is talk about the size, it depends on the outermost shell. So this cell, it elaborated, maybe if it is move outside mean the size increases. Maybe now this outermost shell move inward towards the nucleus, here mean the size is decreases. Okay, so now the size increases and decreases. It is depends on the two concept. Number one, nuclear charge, and another one is outermost shell. So nuclear charge is nothing but this one, that is the proton. Okay, so here that is proton. Now add the electron. For example, in 4f cell, that is adding the electron, at the same time one, that is a proton also, it is added. So this part alone we are saying as nuclear charge. Okay, children. So for example, cerium 57. Okay, 58. So next one 59. So now add the electron here. At the same time, proton, add the proton values added here only. So this part alone we are saying as nuclear charge. Okay, so now the proton means we know very well the charges is positive. Okay, so now this electron, okay, that is the negative charge. Okay, so now compare this proton as well as electron. So now positive here, electron negative charge. So attraction takes place. So attraction means now the size is decreases. Okay, so here to produce the attractive force, nuclear force of attraction, it is created here. So due to nuclear force of attraction, now the size, that is decreases. Can you understand, children? Here positive charge, here outermost shell negative charge. So now plus minus attraction. So attraction move inwards. Okay. So now size decreases. And next is here, this is the outermost shell. The previous cell is penultimate shell. Okay. So here also that is electron, it is present. Here also that is electron, it is present. So both also negative charge. So now repulsion takes place. Here attractive force takes place. Proton as well as outermost shell. Here repulsive force, okay, takes place. So due to repulsion, now the size, that is increases. Okay, so size increases. Due to attraction, the size decreases. Due to repulsion, now the size increases. Are you clear, children? Okay. So now see here that is the electrons, that is crowding. So due to electron crowding, already studied the screening effect or shielding effect. So here also that is produce the shielding effect. So now shield, that is produced between this proton as well as electron. So now no attraction takes place. This is a general concept. Here that is for each orbital as the shielding effect. S orbital, P orbital, D orbital and F orbital. Okay. So S orbital is greater than, sorry, this is P orbital, D orbital and F orbital. Okay. So overall S orbital, that is a more shielding effect. So here poor shielding effect is, that is the F orbital. Okay, so now this is the F orbital, poor shielding effect. So due to poor shielding effect, so now the nuclear charge, that is increases one by one. Okay, already. So now attraction. So positive, negative. So attraction takes place. So move inwards. So the size is decreases. This is the reason. Okay, and another one, this F orbital, poor shielding effect. Why this F orbital, that is it occurs the poor shielding effect, mean it is the diffused shape. Okay, so S orbital means spherical shape, P orbital dumbbell shape, D orbital double dumbbell shape. So this one rigid structure. So this one diffused shape, mean it is spread out. Okay, so due to the reason this F orbital is act as a poor shielding effect. So due to poor shielding effect, now positive and negative attraction takes place. So the size, that is move towards the nucleus. So the size is decreases. So this is the reason for the lanthanide contraction. Okay, this is the causes of lanthanide contraction. Can you understand, children? So lanthanides, that is 58 to 71. Here that is electron added one by one. So here to produce the imperfect shielding of. Okay, if the overall explanation I want to say, that is only one word, mean imperfect shielding of 4f electron by another in the same subcell. Okay, so next one here, that is the increase, there is a 4f orbital. Now add electron one by one. Okay, so this is the reason, and at the same time now the nuclear charge increases, so size decreases. So this is the causes of lanthanide contraction. So first one studied, what about lanthanide contraction? What about lanthanide contraction? The size decreases from lanthanum to lutetium is known as lanthanide contraction. So causes of lanthanide contraction mean, now that is give the point, imperfect shielding of 4f electron. Okay, imperfect shielding of 4f electron. Imperfect shielding of 4f electron. Okay, children. So this is the reason. So now the next topic studied the consequence of lanthanide contraction. So here that is discuss the consequences of lanthanide contraction. Consequences of lanthanide contraction. Okay, here the first topic talk about the basicity. So base. So in lanthanide series, okay, so Ln, the general formula is LnOH thrice. This is a +3 state. Okay, lanthanide, it exhibits as the +3, that is the common oxidation state. So LnOH thrice. So here Ln, the bond OH, just that is, I take this example. Here the bond is, if ionic character it is more, mean this OH that is easily, that is removed. That is OH minus ion, it is easily removed. So OH minus ions move, that is easily removed from this Ln3+, mean that is denoted as ionic character is more. That means here the basicity, base, strong base. Okay, so it is not possible to remove, mean that denoted as that is the covalent character is more. Okay, children. So OH is not removed from this, that is LNOH. So that is denoted as covalent character, that is increases. Okay, that means that is the denoted as the weak base. Okay, so this one denoted as the strong base. So it is not possible to remove me, that denoted as the weak base. So now this concept is explained based on this Bejon's rule. Okay, so what is that Bejon's rule mean? That is size. This formula is inversely proportional to, that is the covalent character. So in lanthanide covalent character, okay. So in lanthanide contraction, the size decreases from lanthanum to lutetium. So from lanthanum to, that is the lutetium, the basic character decreases. So lanthanum, okay. So La3 plus Ce plus 3, okay, etc. So up to lutetium, okay, plus 3. The basic character decreases from lanthanum to lutetium. This is one of the consequences. So next one, talk about this, that is the similarities among lanthanides. So what is the similarities mean? In overall, that is the complete in 4F series, that means lanthanum to lutetium, okay, the atomic radii as well as ionic radii, okay, atomic radii, that is decreases 10 picometer. In ionic radii, that is 20 picometer. So overall difference, that is very less. Okay, we can observe from this. So this one denoted, that is the physical as well as chemical properties are, that is similar. Okay, so no variation, more or less, that is the that is the lanthanoid series element, chemical properties and physical properties, that is similar. Okay, so next one, that is talk about the size. So normally in group, what about the size, whether it is increases or decreases? In group mean that is top to bottom. Okay, so period mean it move from left to right. So in group, the size increases. This is a general concept. Okay, for example, now take this lithium sodium. Okay, lithium, sodium, potassium, rubidium, cesium. Now this one 3, 11, okay, 19. So the sizes increases. Now that is in group, the sizes decreases. We know very well about this concept. Here, due to lanthanide contraction, in group, that is size, it is not, that is increases. Instead of increases, it decreases. Okay, so now seeing that is very elaborately. This one, it occurs due to this contraction, lanthanide contraction only. Okay, so now see here, that is the 3D series, that is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, so next one, this is the 3D series. This one 3D series or first series. Okay, so next one, okay, here ytterbium, zirconium, niobium, molybdenum, technetium. Okay, so next ruthenium, rhodium, palladium, silver, cadmium. Okay, so this one for, that is 4D series or second. Okay, so next and third one, that is lanthanide. So next one, hafnium, tantalum, tungsten, rhodium, rhenium, osmium, iridium, platinum, gold and mercury. Okay, children. So see here alone, that is here lanthanide atomic number 57. Okay, so next this one 58 to 71. It is present at bottom of the periodic table, that is we know. Okay, so next one, this one atomic number 72. Okay, so now, okay, so this one 3D, 4D, this one 5D series. Okay, that is the third. First, second, third, or we are using this word 3D series, 4D series and 5D series. Are you clear, children? Okay. So now here alone lanthanide contraction it occurs. Okay. So now this one group. This one for period. Are you clear, children? So in group generally the size increases. Okay, we know very well. But due to this lanthanide contraction, that is 58 to 71, it is present here, lanthanoids element, but it is present at bottom. That also know very well. So in 57, next is 72. So here, that is egonium. This one, that is the atomic radii 132. Okay, this one atomic radii 145. This one normal. That is 130 to 145, the size increases atomic radii. But here, that is hafnium, the atomic radii value 144. Okay, so just see this value 145 automatically here, whether 147, 148, whatever. But here that is the size decreases. Why decreases? Due to this lanthanide contraction. Are you clear, children? So due to lanthanide contraction, this, that is second and third are 4D and 5D series, the size it is not increases. Instead of increases, the size more or less that is close to each other. Are you clear, children? So 3D and 4D and 5D, the atomic, that is the size is not increases. Okay, so next that this is one of the consequences. So next consequence, this lanthanoid element, it is present, that is it is present in the mineral. It is very difficult to separate. Okay, so if maybe to separate it from the particular part, so we apply the, that is a repeated fractional crystallization or ion exchange method, that is we used and to separate it. Okay, that is the important process. Okay, so next one, due to lanthanide contraction, now you can see that that is atomic radii decreases, ionic radii decreases. Due to lanthanide contraction, it acts as a reducing agent. Children, so for this session, see that what is lanthanide contraction. Okay, so next one, causes. Okay, so in third one, consequence. Okay, so causes means we know very well, that is due to imperfect shielding of 4f electron. Here consequence means that is I discussed 4 or 5 point. One is basicity. Okay, so next one, similarities. Next one, this atomic size, the atomic that is ionic radii, atomic radii, and next one, reducing agent. I hope you can understand this topic. Thank you, children.